In the last video, we deleted a pod and all the data vanished. No errors, no warning, just gone. Now imagine that happening to users upload, application report, or logs. Even worse, a database. If you don't understand storage in Kubernetes, you are not running production. In fact, you are gambling. Today, we will fix that. Hi, I'm Shivam, and this is the second video of the series, Data and Reality Check. Today, we answered the real question. If pod storage is temporary, then how do companies store real data safely? Let's solve this properly. So, a quick recap. Container file system is always deleted when container dies. Similarly, empty directory also gets deleted when the pod dies. So, we need something that survives pod deletion. It is not tied to container lifecycle and it should be independent of pod. And that something is called persistent volume. So this is my cluster. I have one control plane node and two worker nodes. Let's go ahead and we will create a persistent volume. I'm going to create a file called volume. So as we can see, the kind is persistent volume. The name of the volume is demo PV. It has a storage of 100 MI. Think of it as 100 MB. The access mode is read write once. There are three types of access mode, out of which we are using read write once. And this is the host path. So let's go ahead and we will apply this file. So our persistent volume is created. Let's check that. So we can see our persistent volume with 100 MI capacity is created, and so we can see that our persistent volume demo PV with 100 MI capacity is created. Its status is available. As of now, this persistent volume is not being used by anything. So a persistent volume is actual storage in the cluster. It exists independently of pods. It is not deleted when a pod is deleted. But here's the catch. Pods don't directly use persistent volumes. There is an abstraction layer, and that abstraction is what confuses most engineers. It's called a persistent volume claim, or simply PVC. No, don't let the name scare you. In simple words, a PVC is just a request for storage. Imagine you go to a hotel, you don't say give me room number 203. You say I need a room for one night, and hotel gives you an available room. That's exactly what PVC does. Your pod does not say give me a persistent volume named demo PV. Instead, it says I need 100 MB of storage. Kubernetes then looks at available persistent volumes and connects your request to one of them. So a persistent volume is the actual storage, but the persistent volume claim is the request for storage. Your application only creates the request. Kubernetes handles the matching, and that's it. Nothing magical. It's just storage allocation made clean and organized. Let's create one and we'll see that in action. So I'm going to update my same volume.yaml file, and these three dashes signifies that this is a new component which is being created inside this file. So this is a very common practice in production where engineers put all the configs which belongs to one pod in one single file. So as we can see, the kind is persistent volume claim, the name is demo PVC, again the access mode is read write once, and it is requesting a storage of 100 MI. So let's go ahead and we will apply this file. So our PVC has been created. Let's check that. So our PVC has been created, and notice something important, that the status is showing as pending. However, in case of PV, the status was showing as available. So this pending status means that this PVC is not being occupied by any pod. The moment a pod requests a storage of 100 MI, the status will change from pending to bound. But for now, our PVC has been linked to persistent volume. So storage is reserved now. Let's go ahead and we will create a pod for this PVC. Again, I'm gonna edit my volume.yaml file and I'm gonna add my pod configuration inside that. I'm using the same approach with 3 dashes, and here I'm gonna specify my pod details. So as we can see, the kind is pod, the name of the pod is persistent test, it is running an Nginx image, and you see this volume section, this is where we are attaching the PVC which we created earlier, and this is the name of the claim which we created previously. Once we have attached the volume to the pod, we have to specify the location where this volume will be mounted. So we do that using volume mounts and mount path. So this volume will be mounted at /data directory inside the pod. So let's go ahead and we will apply this file. So it says our pod has been created. Now first let's check the status of PVC. As you can see, the status has now changed from pending to bound and 100 MI capacity has been assigned. So let's exec into the pod and we will try to create a file. I am again using kubectl exec -it. This is the name of my pod. And let's go to our data directory where our volume is mounted. As of now, we can see there are no files present. Let's go ahead and create a file. So I'm creating a file called file.txt, and this is the content of the file. So now we can see this file exists. Let's verify the contents. And we can see the contents here. So our file has been created. Now let me exit out of this pod and I will now delete this pod. So I'm gonna delete this pod now. Our pod has been deleted. Let's verify it. So currently there are no pods running in my cluster. I'm gonna once again apply my volume.yaml file and it will create a new pod for us. So it says pod has been created. Let's verify that. So it says our pod is up and running 4 seconds ago. Let's again exec into the pod and we'll see if our file exists or not. So I am inside my pod. Let's go to data directory and we can see that our file exists. Let's check the content of the file and we can see the content is present. This is the difference. Now you understand something important. The pod died, but the storage did not, because the storage lifecycle is no longer tied to pod lifecycle. Persistent volumes are independent. That's how production system survives restart. Earlier, your data was disappearing. It was not random. It wasn't unstable Kubernetes. Instead, this is by design. You were storing data in an ephemeral storage. Now you have separated it from the compute lifecycle. This is production thinking. Now you might be thinking, why PVC even exists? So PVC exists because in real cluster, storage can be AWS EBS, Azure Disk, GCP Persistent Disk, NFS, or any other cloud storage. Developers shouldn't care about the storage. The only thing developers cares about is they request storage and Kubernetes should bind it. And that's the abstraction layer. But here is what it gets interesting. You now know how to persist data. But now we are entering a dangerous territory because storing data safely is not same as running database safely. Imagine running MongoDB, Postgres, or MySQL inside Kubernetes. Now the storage is persistent, which is good. But what about pod identity, restart order, stable network names, and replica coordination? This is where most engineers break production because Kubernetes is great at stateless systems, but databases, as we all know, are stateful, and state introduces complexity. In the next video, We will get deeper and I will answer why databases are hard in Kubernetes. We will talk about identity, storage, ordering, and why even stateful sets exist. Because Kubernetes is not magic. It gives you primitives, but you must understand them. If you think, okay, I have PVC and I can run any database now, that confidence will hurt you. In video 16, we will mature your understanding. I will see you there. Till then, keep learning.